In this lesson, we're going to look at how to calculate maximum and minimum values and where they occur when you add or subtract two different wave functions. So this example says write 1 sin x minus 1 cos x in the form kcos x minus alpha. And later on we're going to find the maximum and minimum values and find where along the x-axis they exist. So the first part of this question is really just to change this into the form kcos x minus alpha. We just do that as normal. Use the addition formula to multiply the brackets out, so cos, sin with a different sign in the middle. Multiply through by your k, keeping your cos alpha at the front, and also your sin alpha at the front. And then compare coefficients. So k cos alpha is the coefficient of cos x, so we look up here and see the cos x, and we can see here there's a negative in front and really a negative 1 there, so that means that's equal to negative 1. Next we'll look at k sin alpha, and that's the coefficient of sin x. It's just a plus here, so we look up here and there's a 1 really there, 1 sin x, so that's going to equal plus 1. If we divide by k, we get negative 1 over k, and same here, we get 1 over k for sin alpha. So we've got adjacent over hypotenuse and opposite over hypotenuse, so opposite side is going to be the opposite angle, so that's 1, and k is going to be diagonal opposite the right angle hypotenuse. Negative 1 is your adjacent. A bit of Pythagoras, k squared equals 1 squared plus negative 1 squared, so that's going to be root 2. Just repeating this down here, cos is negative, sin's positive. So if we tick where cos is negative, that will be here and here. If we tick where sin's positive, here and here. So we're looking at having your 2 ticks in the second quadrant. So when we work out our phase angle, we're in the second quadrant. So tan of 1 over negative 1, tan alpha, work out your relative acute angle, so inverse tan, the positive value here, so that's just 1. And if you inverse tan 1, you get 45 degrees. So the angle we're looking for is in the second quadrant. We have to subtract from 180 and get 135. So let's rewrite this here in this form. We've worked out k is root 2, we've worked alpha out to be 135, so we'll write that here. We're now going to turn our attention to how to calculate the maximum and minimum values. So this is a cosine wave that's been shifted. It's been shifted by 135 degrees. I'm interested in how high and how low it goes. So this value here is how high and how low it goes. This is amplitude. So this cosine wave goes up to root 2 and down to negative root 2. And that's how you get your maximum and minimum values. But we want to know where these exist. I don't want to just know that the maximum is root 2, I want to know where along the x-axis this occurs. So I have to solve an equation to do that. We also want to work out where the minimum value is. Again, we want to solve an equation to do that. Now, if we just focus on this part here, we're going to look at the maximum first. So we'll look at the maximum value of root 2 first. Now, the maximum value of root 2 occurs when this bit in the yellow highlighted here is equal to 1. The cosine wave's maximum value is 1. If you take the root 2 out of the equation, you just think how high can a cosine wave go? It's 1. So the maximum value of root 2 occurs when this is 1. So we set an equation up saying that cos x minus 135 is equal to 1. Now, to undo this and to work out x, this will tell us where the maximum value occurs. So inverse cos 1 first. And if you think of the cosine wave, and you think of 1, then that happens at 0. It also happens at 360, but when we add on 135 to this, we're going to get the same figure really. So if you add on 135, you're going to get x is 135 degrees. If you took into account the 360, you would go forward 135 from 360, and then you would go back 360 to get in the range of 0 to 360. So there'd be no point in putting 360 degrees there. However, it's sometimes good to put the 360 in when you've got a plus here and you want to subtract. Otherwise, if you had a plus 135, you wanted to subtract from 0, you'd end up with a negative value. In which case you could go forwards 360 degrees. Okay, so if we turn our attention to the negative root 2, this occurs when this highlighted bit in the yellow is negative 1. So same idea, you want to undo this to work out x, so inverse cos, and this occurs in the cosine wave at 180 degrees. Then to finish off, you add on 135 to 180 and you get 315 degrees. So the minimum value of negative root 2 occurs at 315 degrees. The maximum value of root 2 occurs at 135 degrees.